Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I am one of the event planners for the Redmond Reactor space. Before we get started today, I've got a few things to go over. So if you could please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenters. We definitely encourage engagement in the chat, but we ask you to please be mindful of your commentary, remain professional and on topic. We will share useful links throughout the chat, so keep an eye out for that. And the session will be recorded. It's going to be available within 24 to 48 hours on the Microsoft Reactor YouTube channel. And that brings us to today's session. It's scheduled to run approximately for 1 hour, and will definitely be time for questions throughout. So if you would be patient, I will now turn it over to our speakers.
Great, and it looks like I'm unmuted. Can everyone hear me? Just thumbs up, thumbs down. Okay, so we're off. So hey, welcome to RAG Hack. This is just an awesome event, and it's one of my favorite topics within the AI realm. So just really happy to be here. Let's go ahead and see if I can get this slide to advance. That's trickier than AI, folks. So yeah, today's session is what I like to call Spring AI and RAG Feel the Power. My name is Mark Heckler. For those of you who don't know me, I'm a principal cloud advocate of Java and JVM languages here at Microsoft. If you have any questions, comments, or feedback during this session, that's wonderful. I will be periodically stepping away from the comment section to focus on coding, of course, but then I'll pop back in periodically to catch up on questions. So it's kind of a slinky effect there. Not ignoring it, just having to kind of focus here and then switch back. So please, if you think of something, throw it out as a question. If you think of something 5 minutes after the session ends, this is my problem perpetually. You're not alone if that happens to you. So please do feel free to reach out to me via email at markheckler@microsoft.com, or better yet, on Twitter/X, whatever we're calling it today. Socials, I tend to probably respond a little faster than email, but anyway. So today's agenda, so I'm told I only have an hour. That's super disappointing, but I'm kidding. We should be able to wrap it up well with good Q&A within that time. At least we'll give it a shot. So today's agenda, I'm going to do a quick review of AI concepts. I don't want to spend excessive time on that because I know a lot of folks are fairly familiar, but frankly, this is a very new domain, and things are evolving very rapidly. So I don't want to just skip them either. Because even those of us who have spent some time in there are surprised almost daily, and that's a good thing. I always remind folks that when the ride starts going kind of fast and you feel a little sick, don't get mad at the ride. It's kind of the excitement of it. So stay engaged, enjoy, but be prepared to be relearning things constantly from the time that you wake up to the time you go to bed every day. So we'll quickly review the AI concepts. We'll talk a bit about the value proposition, which is RAG, and then we'll go into some implementation options. I like to code things live, so there will be mistakes, probably. I mean, I try not to make those, but being human, occasionally things creep in, and I think that's a value because I think, especially when I run into something that I forget to add in or accommodate, that's good because if you see everything go perfectly, it's very easy to think when you run into an issue, maybe when you're first time trying something, kicking the tires on it, it must be me. Well, it may be, but chances are it may just be something that's very common that we can work through together. So that's a good thing, and that's kind of where the action comes, because we'll be coding things live here together. And then I'll share the code repo, other helpful links. I did put those in the chat or to be shared. So I don't know exactly timing, but yeah, okay. So we're starting to see them show up now. That's good. Check those out. Not during the session if you would, but perhaps after. So to kind of get things rolling, I like to at least cover some basic AI concepts. I won't give a PhD dissertation on these things, but I will kind of, from a practitioner's perspective, cover a few of the key points. And I think, again, this The specifics of this changes very quickly. However, the general concepts and general lay of the land doesn't change terribly quickly at all. So the framework that everything fits within is fairly consistent. It's just that things within that framework tend to iterate rather rapidly. So we'll talk a little bit about large language models. We'll talk about retrieval augmented generation, RAG, and then we'll discuss, well, a language framework anyway. So when you start looking at utilizing AI within your applications, you start looking at things called large language models. And that is, I mean, it's just that. It's a language model that is rather huge in scope. You probably or may have heard of the term small language models. Won't be discussing this today, but you also, as we go through things, I'll probably be throwing things out. I like to talk as I code, so I'm not sure exactly where some of these things will come into play during our conversation today. But you'll also see various different sizes of language models, large language models in terms of parameters. So within the concept of large language models and of course small language models and any language models, you'll see various different sizes and scopes. But first, I will say this: within large language models, you're seeing kind of a convergence in a lot of ways. So initially, there were models that were specifically designed for creating embeddings, which I'll get into momentarily. As you see down further in the screen, you still have models that are created that are purpose built for supplying a text prompt and getting text back. So text-based models. You have models that are for generating images, for taking images as an input and producing text as output. And then over time, you see this kind of convergence. Now with convergence, with the more capabilities that a single model might have, that kind of, just logically speaking, will tell you that it's going to have more capabilities, it's going to have more size, more heft to it, to that model. So there are various different use cases that might apply to a specific model for a specific purpose, a purpose-built model, or in many cases, of course, as things are refined, as they're improved, you might find that a general purpose model actually serves a lot of those needs well and really doesn't, it streamlines things, it simplifies things, but it really doesn't add to your compute costs, which we'll talk about probably in the next screen or the following one after that. So there are various different ways of approaching this, and I'll offer some recommendations as we go as well. Sizes, now that's where you come into parameters. So you can have models, even within a single model type, model designation, that will have different parameter sizes. And that basically is the power, the capabilities of that particular model. It's a way of using a particular model on a smaller hardware offering, a smaller cloud offering, maybe getting a faster response, but it is less capable because, of course, the fewer parameters it handles, the less capability that particular model has. You also have different providers. So you have, within those different subsets, you have a different model that might be provided by OpenAI or by Anthropic or by Microsoft. You have a lot of different models that are offered by different providers. Many times there's an overlap, right? Because many different offerings are available in many different places. However, you have the option to choose your provider for a particular model. So different things might go into your decision as far as what models are offered by that provider, what security constructs they offer to make sure that your data is secured within that context, different contracts you might have with an existing provider, et cetera. And then you have local versus cloud-based, which actually goes back to some of the things we've talked about earlier. Well, all of those basically, but especially the things in terms of the models and the sizes, the purposes and the sizes. So I don't want to get too far into that just yet because I will be covering that in another slide. However, you do have the option to run some of these models locally on your machine, your laptop, your desktop, on even very small systems on a chip. However, of course, you're going to be much more constrained in terms of what is practical to use within those tighter constraints. Versus a cloud-based model, kind of the sky's the limit, if you'll pardon the pun. So you can bring to bear much more compute resource available to focus on a problem, to use a bigger model, a more capable model, if you're using a cloud-based provider, because of course they have more resources than perhaps your desktop. That actually applies to the next topic as well, retrieval augmented generation, because you can run a vector store, and I'll again momentarily get into that. You can run that locally. You can run it in the cloud. But obviously, when you run it locally, you're going to be chewing up some resources as well. Not nearly as much as the LLM. I mean, let's be real. It's a database, and we've run databases on smaller machines for a long time. So you're less constrained in that regard than you are for large language models. But obviously, everything takes resources, so that has to factor into the conversation as well. Anytime we talk about retrieval augmented generation, you'll hear a couple of terms thrown out quite frequently and with abandon. And one of those is embeddings. Pardon me. When you're thinking of embeddings, the way I like to explain it is that if you were trying to gather knowledge about animals in the animal kingdom, and you were trying to be able to do a similarity search to see what other kind of animals are closest or most similar to a particular animal that you'd like to specify as a starting point. So what you would typically do if you're going to populate some kind of a store of knowledge for this concept, you would generate embeddings. And embeddings are just a way to break down a particular thing into various different dimensions, various different characterizations or characteristics. So for instance, in the earlier example of animals, you might have a domestic house cat. Well, a house cat has 2 eyes, 2 ears, 4 legs, a tail, generally speaking. Obviously, there are variations on everything, but you would have a certain size range that's typically encountered and things of that nature. And you would save all of those different dimensions on that particular thing, in this case, a domestic house cat, to your data store, your vector store in this case. And then, of course, you would do that for every animal in the animal kingdom that is identified at this point. And then you could search and say, what is similar to a domestic house cat? And you might find a domesticated dog as part of that. So within that same similarity search, you might find that, well, a rhinoceros isn't very similar to a common house cat. But if you wanted to search particularly maybe a different way with a different set of search criteria, you might find that the closest or a close similarity to a house cat would be a lion or a tiger. So it depends on how you want to search that, but each thing that you save into a vector store has a certain number of dimensions, a certain number of characteristics that you're storing, so that you can draw these, or that the vector store can draw these similar constructs, similar associations between these two entities or multiple entities. I like to consider it kind of like an overlapping Venn diagram. So you have Venn diagrams that, based on your search criteria, the circles will change, they will shift, and you'll find that based on a certain search criteria, this particular circle will be here, but if you change your search criteria, it will be here, and you'll have different things that will fall in or out of that circle. The vector store, as I mentioned, is just the way to store that. So you store things in this numeric assessment, or all these different dimensions in a vector store, so it's fast, it's searchable, and allows you to quickly, or allows the LLM to quickly retrieve that information and present that to you in a way that's meaningful. There are various different language frameworks. I'm a Java person, so Java and JVM languages, so things like Kotlin, Groovy in the day. So if you are a Java person, we support. I mean, there are ways you can consume APIs that are REST APIs, etc. But we support 3 main language frameworks to make your job easier, my job easier. Semantic kernel, which we provide the development resources for. LangChain4j, which we also contribute to, and huge community-based project, and then Spring AI, which we also provide, contribute code and content and docs to, and it's community-driven and led by our partners at Broadcom. So they're all 3 very good language frameworks. I focus on Spring AI. Spring has a large market share within the Java space. I'm a huge Spring fan, but my colleague and manager heavily contributes to and encourages use of LangChain4j. So we just don't care. We want you to have a great experience regardless of what it is. And we support some great work within RAG and Java, regardless of your tool of choice. So the value proposition. I've made no bones about this. AI, like every other tool that enters a technologist's field of vision, is heavily overhyped. Maybe not initially, but at some point it becomes heavily overhyped. And when that happens, it's very easy to lose sight of the things that really, really provide you value. because most tools, the reason they are overhyped is because they do provide or can provide a lot of value. And RAG is one of those things that really, really excites me within AI, the field of AI, because it allows you to turn an AI loose on your data. Now, every one of us works for an organization, and some of us have worked for organizations in the past or will in the future that has a mountain, an absolute, just more data than you can imagine that could be hugely valuable, hugely useful if we could just get to all of it, if we could just associate it with everything else that we have. You might be surprised to know there are still companies out there with physical data, physical files. It makes me shudder to think about, but it happens. You occasionally run across that and you just think, why? But all this takes time, right? But even more so, you see a lot of digitized documents, things that were saved because they have to legally or be saved, or because they have to be retained for that time that they might prove useful or valuable as a reference. But it's been very hard traditionally to find that needle in the haystack that you might need when you need it. Well, if you were able to take those documents, many of which aren't necessarily that easily accessible or easily consumable, it's been a very manual process. Let's say you have a PDF of a contract that your company issued years ago, 7, 8, 10 years ago. And it's there, it exists, you just don't know where it is. It's not well filed, it's not easily searchable. Think about if you could ingest all of that into a vector store, all of that information, and turn an AI loose on it. And I typically use that AI term kind of generically, because when you're dealing with different models, large language model, small language model, I use it generically, even though I know I'm intentionally being non-specific on that. But if you can turn an AI loose on your data, all that mountain of potentially valuable data, and have it quickly return valuable summarized information, that is huge. That's something that every organization can benefit from and really kind of take you to that next level. It's something that once you see it in action, you can't unsee it. And that's where I really get excited, because that is a huge value prop versus some of the other things that are cool, admittedly, but perhaps a little harder to provide real value for your organization. This is huge. This is something that can, like, out of the gate. So to get on to implementation options, I'm going to take a sip here for a moment. As a developer, and this is talking about it from a development perspective, right? When we deploy, when we actually go to production, there are a lot fewer options in terms of good options that you want to employ as a developer. So I look at that development cycle as kind of where you get out in front of things very quickly, hopefully very quickly, and you can run all of these things locally. So whether you're talking about the LLM, the SLM, whatever, you can do that locally. You can also run your vector store, vector database locally. You can run everything locally. The problem is, of course, resources. But before I get too far down that road, you have container runtimes, execution engines, so things like Docker or Llama, any kind of container execution environment, and all of those things give you options in different ways. The pros are there's a huge variety of those, as I mentioned. There's a huge variety of different, let's just use LLMs as an example. LLMs you can run from Llama, and that's great. And it's effectively zero cost. You can just do an Llama pull or load, and you can run that locally. Everything's great. The problem is that all of that is hugely resource intensive, and sometimes it's painfully slow. So what you wind up doing in order to actually have resources left to develop with is you typically go with a smaller parameter model. You go with a much leaner model, which of course is pretty restrictive on what you can do vis-a-vis the much more fully capable model, the billion parameter model. So there are trade-offs, and there are trade-offs even in a cloud environment, but of course you're much more constrained in the environment you have running locally on your desktop. So you wind up getting very quickly into that trade-offs realm. And if a smaller model works for you, that's great. That might be a good option in terms of running things locally to develop with, and you can get good results. That's great. However, that when you really want to do the full rigorous testing, you're probably going to be looking at a cloud-based option. And that is in terms of the LLM as well as the vector store. I say that again, and I mentioned this before, the LLM is the hugely resource intensive resource. The vector store much less so. So what I wind up doing many times in my development process is using a cloud-based LLM and using a local vector store. And that works pretty well. It's a nice balance. The cloud-based options, again, there are various vendors, various outlets. You've got, I don't want to say unlimited power and speed, but it's very, you're going to have a lot more trouble running into the edges with that than you would a local LLM. So that's amazing. The cons are costs, right? Because you're using somebody's API, you're using resources that are provided by a cloud provider, and all of that can incur costs. Now, I will say this, your mileage varies. I heavily encourage you to keep a close eye on your costs and your expenditures, because this can get away from you really quickly. It's like any cloud-based resource. If you're not watching things, you get ugly surprises, and you don't want those. However, I find that based on a development stack, a development effort, when you're doing something, the costs they don't ramp up that quickly. It's when you start looking at scaling and things like that. But again, keep an eye on it, because it's always better to catch that early than to get a huge surprise at the end of the month. And then in terms of deployment, as I mentioned, it's not in scope for this session, so I won't necessarily be talking about particular deployment options, but effectively what you're going to be looking at is a way to deploy that seamlessly to a cloud-based environment and use cloud-based resources in terms of the LLM and the vector stores, etc. So let's see, before I go on to the next thing, let's stop here and just see if there are any questions here. You are not too late. Hi, Paulina. So yeah, just welcome. This is a stream you can jump into and jump out of. So welcome. Hope you're a Java developer. If not, if you want to learn, Java is the best language. I mean, let's be real. So I'm kidding. It's a great language. So yeah, just dive in, and I'll be stepping through things. I don't assume that you come in with a particular set of knowledge. I like to talk, so I like to cover it all. But if I do skip over something that you feel like I went from step 1 to step 7, please ping me in the chat or ping me afterward. I'm happy to help fill in those gaps. Hi, everyone. Yasir, everybody else. Yeah, so I'm going to go ahead and keep rolling. And by rolling, I mean getting into the code, because that's really what we're here for, right, is to hack. So I will jump out of here and go to here. Oops, that's the wrong place. Okay, yeah, that's the repo, as you've seen in the link in the chat. But we're going to start here. Now, I mentioned earlier that within AI, there is a rather rapid evolution. So things that might take 80 lines of code today might take 40 tomorrow, and by the beginning of next week might take 2. And that's a good thing. Please don't get frustrated with that. I create examples, and I'm constantly going back, and stuff that was really hard won becomes very easy. And frankly, that's something that as a developer we should really, really relish, because that means that your framework, and that's one of the reasons why I encourage using a framework, it's picking up more of the heavy lifting for you, so you don't have to continually handwrite mountains of code. It also gives you the ability to be a little more abstract. So the useful abstractions allow you to, if you want to switch different models, if you want to switch different vector store implementations, things like that, it makes it easier to do that while still getting all the full power of each one. So I'm a big fan of Spring, as I mentioned. I used to be on the Spring team and still work with a lot of them very regularly, including the Spring AI team. So big fan of that and their work. And that's kind of where I want to start today, is with a Spring Boot application. Now, this is the Spring Initializer. It allows you to springboard into an application very quickly. So it doesn't write code for you other than the main application class, main method, but what it does do is create your project structure, your application structure for you very quickly and easily. So it gives you that early jump. And then I'll get into more of the Spring Boot capabilities if you're not familiar. Is anybody, I guess I should ask this, I wish there was a poll here, but is anybody not familiar with Spring? Is anybody familiar with Spring? If you just kind of toss your thoughts out there, that would be something we can come back to later. But I'm going to go in, yeah, not familiar. Okay, that's cool. So I'm going to, let's just start from 0. The Spring Initializer allows you to choose your build tool, and it also choose your language. I'm going to stick with pretty much down the middle of the road with Java and Maven. I'm going to use the current version of Spring Boot. You can choose, look ahead a little bit on one production version back. But I'm going to keep, again, I like to stay kind of in the middle of the road, because that way the road is wide, right? So I'm going to just change this to the hecklers.com because I can. We'll call this rag hack. Yeah, why not? No, I'm just kidding. Rag hack. There we go. And this is our demo project for rag hack. Yeah, love it. All right, and I'm going to add a few dependencies. And if you're familiar with Java development, most development, if you want to do anything of any substance, you're going to add a library for this, and a library for that, and a library for this. And it basically is at a functionality level. With Spring Boot, you elevate that to, and again, it's that abstraction, right? So it's elevated to capabilities, because if you're defining and determining, if you're building a web app, chances are you want to be able to listen for requests, to respond to those requests, and in the middle do something, right? And all of those things can involve different libraries, different components. However, it's a capability. So with the Spring Initializer, it allows you to choose kind of groupings. And each of those groupings, each of those capabilities includes all the different libraries that it takes to do that. They've been tested with a particular version. They've been synchronized, so you know they work. And if there are issues, of course, you can override them. But generally speaking, everything upgrades in sync, and it makes your life so much simpler as a developer. So I like to start with that. I'm going to bring in the Spring Web capability, because that gives us the ability to define that web API. And then I'm going to bring in Chroma for my database. Again, I'm going to run this locally. I am going to use OpenAI. And again, you can do anything you want. You can run a local LLM, et cetera. But I find that I like to split the difference, right? And keep things kind of in the middle of the road, and let you choose from there. But this is a nice balance to get us started for today. Generate this, and I'll generate that project. I guess I actually should show you before I do that. I'll show you in the IDE. That's no big deal. So I'm going to open that. I'll unzip that into a project, and we'll go here. And I actually left that over here. I don't care for that, because what I want to do is bring this over, expand this, and here is my project. Yes, and it's loading up in IntelliJ. Now, I use IntelliJ for some things. It's kind of the favorite IDE for Java developers, IntelliJ IDEA. And I use Visual Studio Code for some things. All of it works really well. But again, I'll keep it consistent. This is probably what I use 52% of the time versus 48. So let's go here to our, let's start with our POM. Our POM is our build file. And within that, we can see the dependencies that I brought in. So we have Spring Boot Starter Web. And of course, I zoomed in on the wrong one. There we go. So Spring Boot Starter Web, that's our web API capability that we're bringing in, which is also a build, a BOM, if you will. So you have also the Chroma dependency, and then the Spring AI, OpenAI Spring Boot Starter as well. So each of these is a bill of materials that if you go into and you drill in there, you can see what that includes. And of course, again, it brings in the full capability. So you have all of this at your fingertips without having to specify each of those individually, which is really nice. I'm going to add one more thing here, one more dependency. And we'll call this Spring, let's see, Tika. Yeah, that's it. Because what I want to do is to be able to store documents, to pull in documents from wherever I might find them, and to store them in our vector store. So that's our starting point. I also want to, in our application properties, I want to indicate that we're going to initialize our schema. This allows our application to go ahead and create the memory structures to use that schema within Chroma for it as a vector store. Kind of an oversimplification, but it pretty much answers the mail there. So this is all the code that is created with the Spring Initializer. It's very simple, but it just gets your application running. It's the main method for a Java application, and then the annotation for Spring Boot as a Spring Boot app, which is a meta annotation as well. I could drill into this, but it's not particularly relevant to our topic today, so I won't. But if you want to explore that, by all means, feel free to do that. But it gets your application, when you start it, it kicks off an auto configuration. And that's very important to what we're going to be doing today, because it allows you to focus on what you want to do and not necessarily the mechanics behind it as much. Because with Spring Boot applications, based on what you provide in terms of code and what is on your class path, and properties that you provide, it will auto-configure your application based on those things. So the fact that I have a dependency in here for the Tika document reader, Apache Tika, it will configure certain objects or beans, Java beans, to act for you or be ready to act on your behalf to do things that you want to do. Same thing with OpenAI, same thing with Chroma, because just by including this dependency in our class path in our project, it tells the application that, hey, I want to interact with a Chroma database, and it creates the underlying beans to do so that you don't have to. You don't have to specify those manually, which is a super time saver as a developer. Pardon me. Okay, so the next thing that I want to do, first thing really, is go ahead and create a new class here. A little bit of lag here. I guess I just got enough stuff running even now, but it's a little bit laggy. So I'm going to call this a RAG controller. And I'm going to make this a REST controller because I'm going to keep it simple, but I want to be able to see what we're doing, right? And this allows us to define a REST API. You can see that Copilot is jumping in here and saying, hey, let's create some value here. Let's go ahead and create these methods, and that's fine. I could do this. It's not exactly what I want, but it's based on my code that I've done in the past, and that's not a bad start. So I have a describe method. I'll just do a get mapping on that, and that's fine. If we want something to, when somebody starts our application and hits an endpoint, without specifying anything, it gives us kind of a guide to go through and operate our application. This is a nice way to do it. Certainly not required, but I like to do that as well. But what I want to do is specify a few different environment variables, or excuse me, losing my mind here, member variables that I'm going to be using throughout our application today. So I'm going to be using a chat client, and of course I need to import that, and that's fine. We'll go ahead and go from there. I also will at some point need to use a chat model. I'm not going to need that just yet, but I want to bring in a vector store. Let's see, let's bring that in. Let's import that, provide the import to our application. And then you can see that it still has a red line. And that's because we've defined a member variable that is one of those things, but we haven't initialized it in any way. So we want to add those as constructor parameters. And this is where Spring's inversion of control and dependency injection comes in, because the auto configuration provides these beans. We need to actually get those into our application class to use them, our controller class. So that's what we're doing. We're injecting them via our constructor. Now we see that there's a problem here. This is, well, let me see if I can just put this up. Could not auto wire. There are no beans of chat client type found. That's because Spring Boot's auto configuration doesn't create a chat client for you by default. What it does do is create a builder by default. So we'll call this builder, because there are many times that you actually want to do something and configure that builder specifically before you create that client from it. Now I'm not at this point. It has no direct relevance to RAG, but there are other very valid reasons to do this, as I do in some of my other sessions. I'm not going to mess with that today, but I'm going to be injecting that builder, which is auto-configured, and using that to create a client that we can then use in our application. So this actually does just pretty much nothing at this point, but I do want to just see if it works. Always good before we get too far down the road to see if it works. So let's see here. And there we have that. So let me just do a Maven Spring Boot run. Now I like to go to the command line, and the reason I do that now is because I have certain environment variables that I must set for instance, my OpenAI API key and things like that I don't necessarily want to share. I don't want to show, so I don't want to put them in my application properties file like I did with the initialized schema, but I do want access to them. And Spring Boot applications will check your environment for certain formatted environment variables and bring those in automatically for you, so you don't have to. That's why I run everything from the command line, that and have it. But that's I'm going to be spending a lot of time here today out in the terminal. Hope you're okay with that. So we are up and running. So I'm going to open another window here and another tab, and just do :8080. I like to use HTTP instead of curl, but if you prefer curl, great. HTTP is curl for humans. And so I'm just going to, and of course we can put localhost, but with HTTP it assumes that as the default if you don't specify. Assumes port 80 if you don't, but I'm going to be hitting port 8080 for application, and there we go. So it is working. It's retrieving from our endpoint that we created here. Thank you, Copilot. So it's just coming back with describe, the described contents, and it's showing that. That's great. So now let's get on to the good stuff. I like to establish first that the application works, and then a baseline endpoint that we can use for non-RAG queries. So we're just going to ask want the ability to ask the LLM some questions. So I call this query. I'm going to make this a request parameter and string message. That's fine. It is actually, we should provide some kind of a default value, right? So we'll say, what is the meaning of life? And that's our default value for that. We don't want to return null. That was a nice thought. But look, Copilot is just really doing our work for us here today. This is not a Copilot session, but it's kind of nice to see. It helps speed things along dramatically. I'm a fast typist, but Copilot is faster. So I'm going to be using the client, the chat client I injected here. And I'm just going to be creating a prompt, supplying the user message, and calling the AI endpoint and retrieving the content. There are also ways that you can retrieve the actual full response as JSON, and I'll probably show you that here in a little bit. It's not specifically relevant to our conversation, so I'll say that for later. But you can do that as well. So really quickly, let's go back and rerun this. And let's say HTTP. Well, we can just say 8080 and query, right? Because it actually has a default value for the parameter if we don't provide one. So we're started. Let's go ahead and query and say, oh yes. Well, we should probably add the get mapping here so we have something to map to. That's helpful. While it's starting, let me go ahead. I don't want to take a second here. So we'll do this and ask, what is the meaning of life? Oh, hadn't gotten there yet. Sorry about that. Getting ahead of myself. We're up and running. So now we'll query, and we'll find out what the meaning of life is. And this is actually a pretty good response from OpenAI, right? By the way, I'm using the GPT-4o Omni model. But again, your choice of model is entirely up to you, as is your choice of philosophies. So the meaning of life, it covers a philosophical perspective, a religious perspective, a scientific perspective, personal perspective. Very nice answer. So we know that's all working. I'm going to quickly hop over here and see if we have any questions yet. Tika is an open source project. Yes. Oh, that's not a question. That's an observation. So that's good. Let's see. All right. So we're good. Carry on. Let's see. Back here. All right. So we have a non-RAG query, but what if we want to, well, we will want to populate a data store with certain documents. I've already done this in the interest of time, but I do want to bring in, show you how to write code that will actually allow you to do just this. So I'll do a get mapping, specify that first, so I don't forget, and populate. That's not terrible. It's not great. It's a good start, right? So we're going to provide a file path, and that is a requirement. So I'm not going to indicate a default value. I'm not going to indicate that it's not required, and we're not going to implement or have a not implemented yet response. So what I want to do first is define a logger, just so we can logger factory. There we go, and import, so that we can use that to log our progress as we go. It's just kind of a good habit to get into. The next thing I want to do, though, is define our import file, what kind of file it is, import file. And I'm going to take the file path, and if it starts with something, in this case, oh, good. See, it is finding my old code. That's a good thing to see. When it works, it's a lovely, lovely thing. So if it starts with HTTP, I'm going to make this and assume this is a URL resource. Nope. It's not there yet. That's fine. We'll get there. And if not, we'll assume it's a file system resource. So there we go. Just takes a little bit to catch up. And unhandled exception, we'll add the exception to our method signature. That's good. And then what I want to next do is provide a document reader, and we'll use our yeah, Tika document reader, right? Yep, and we will grab our import file, which we have specified here. That's good. And then I want to define a splitter. Splitter equals token text splitter. Nope. New token text splitter. Text splitter. There we go. And I don't want anything in there just yet, right? So we'll keep this nice and tight. And then I want to log this. So logger.info, and let's just do a populating vector store with, and let's just add the file path. This isn't very clever or cute. It just works, right? So the first thing I want to do is grab our Tika document reader, right? Document reader, and we will just do a get. And what a get does is return a list of documents from whatever we're getting, and that's fine. But what we want to do next is take that set of documents and we'll split it. So we'll take our splitter and we'll apply that, right? And that looks pretty good. And what we can do from there is just add whatever we get back from that to our database. And that allows us, and of course we want to log that. Yep, that's fine. We also want to log when it's complete. And yeah, that's kind of what we put. So vector store populated with, vector store population complete. Sure, that looks good. So this allows us to populate based on files that we find online or files that we have locally, and allows us to add that critical information to our vector store. I'm going to go ahead and rerun this, and I'll show you the things that I've already added. And of course, anytime you do this, you have to, any context you have, the better contextual documents you have, the better your results are going to be. Everybody has, if you're working in insurance, it may be a lot of insurance documentation, so that's your domain. If you're working in law, you might have legal documents, and that's huge. That's a huge domain that you need to address. Regulatory, so if you're in energy and things like that, financial services. I don't have any of that specifically, but what I do have is I'm a pilot as well. So I have to adhere to FAA regulations and guidance. I have an aircraft that I have to know the specific numbers for, and that's my domain that I like to work with. Obviously, I'm a software developer first, pilot second, but I love to fly, and that's something that if you don't do well, it can actually be very detrimental to your health in the short and long term. So you as a pilot, you have to know a lot of regulations. And I find that even though it's not a domain that everybody's involved in, just like they're not involved in insurance, financial, energy, government, whatever, it's something that everybody can relate to because everybody has a mountain of information that they have to absorb. So what I do, what I have done is populate my data store with things that are specific to aviation. So the code for federal regulations, airspeeds. I have the instrument flying handbook, instrument procedures, aviation weather handbook. I've got the aviation instructors handbook, the aeronautical information manual, the federal aviation regulations, all of that stuff, a pilot's operating handbook for the aircraft that I fly. All that stuff is in there, right? I have not populated it with everything, though. There is actually one that I haven't dropped in there yet, so I'm going to try this. Let's hope this works, live and untested, right? Oops. I just wiped out my, there. No, that's fine. Yeah, here we go. So populate, and our file path equals, and we will grab, we already have the pilot's handbook of aeronautical knowledge. What I don't think I have in there is I'm looking for something fairly short because obviously this takes time to calculate all of these numbers, the dimensions, and to save them. So let's grab this checklist. That would be fine. That should work. Should work. I always think, oh, I actually didn't put the full path in there. That's embarrassing. So users, Mark Heckler, files. Oh, still didn't get it right. See, this is what happens when your fingers fly faster than you talk. So we'll go over here and look. It's splitting it into 4 chunks. It is a single document, but it's splitting it into chunks. It's already populated. So now we're off and running. So that's good. Now we can test it. However, we don't have any code in there just yet to test it. So let's go ahead and add that. we have the ability to call an LLM and ask it questions, but we don't have that specific information. Again, this is where RAG really comes into its own. So I'm going to skip up above this, and we'll add a get mapping, and we'll say RAG. That's good. And it doesn't look half bad. So let's see, I hate just the short ones, so we'll do a get RAG response. And then while I'm at it, I'm going to just change this to get non-RAG query response. Sure, that looks good. All right, so if we go to the /RAG endpoint, then we will have this. I'm just going to add a default value here. I like to add default values where it makes sense. I'm just going to say airspeed. So if I don't put anything, it'll come back with airspeeds. Advisors, this isn't acceptable at all. What we want is a new question and answer advisor. And of course, we'll provide our vector store database for it to search, and then we'll provide the default search requests, the defaults. You can actually provide a filter expression in here if you want to specifically tailor that. We don't. We want the full power of retrieval augmented generation and no limits, right? And nothing that we're going to be sifting and sorting on at this point or filtering on. So let's try that. Let's go back here and rerun this. I do want to start with something here first because I like to show this. If we go to 8080/query, and this is not specific. This is not going to be referencing our data store at all. This is just a standard query. So if I do a message, did I do message on this as well? Yes, I did. Good. I like to keep things consistent. So what are the airspeeds and their corresponding V values? Let's try that. So if we do a query and we ask generically to the LLM, what are airspeeds and their corresponding V values? And you'll see things in pilot terminology like V0, which is your flaps extended speed. Oh, I didn't put, did I put message? Oh, oops, message equals. There we go. That should work a little better. It defaulted to the default value, which was the what is the meaning of life, and came back with that since I had a typo. And this is very good generic information. We're just asking the LLM. There's no RAG involved whatsoever at this point, but it's giving us kind of a rundown of VS0, VS1, VFE, which is the maximum flap extended speed. These are all very important when you're flying to make sure you stay alive. However, if we want something that's specific to our aircraft, I actually am going to hit the RAG endpoint with the same exact query, which is going to reference all of those documents that I've already populated into our vector store. And this should be more specific to our needs. So what it's doing is it's checking for any related documentation, documents that we have, and then it's using the LLM to sift that and provide it in a consumable format that's useful for us. So this is good. It's telling us, once again, kind of the general information, but it's saying, hey, for VOI, it's 79 knots indicated airspeed. You have different flap settings you can use. Here's the crux of it right here. Let me see if I can skip back up. Yeah, so it's saying, here are the V speeds for specifically for a PA-28161 aircraft. And this is where it really gets interesting because now it's not just generic, it's very specific to the documents that you have uploaded, that you have provided in your vector store. And it's very quick, right? We didn't have to search through mountains and mountains of manuals to find this. It's right there. Now, this is awesome, undoubtedly awesome. So let me see, I have some other queries. I can't remember them off the top of my head. Let me see if I can go back through my list over here because I like to keep a kind of a bunch of them that I can, airspeeds and V references, that's fine. Yeah, so this is another one. So this actually doesn't matter so much on this particular one. What are the specific transponder codes a pilot must know? But this is good, useful information, and it tells you this. Yeah, so this is a way that you can quickly reference information you need, again, to stay alive, to operate efficiently. And if you're in a, let's say, financial services company, you can find, well, let's use legal terminology. You can find case history. You can find references when a particular argument was used, when a particular, perhaps a particular court was used, and allows you to zero in much more quickly on very, very relevant information that is often hard or impossible to find, and certainly in a limited time frame. Now, what I want to do next is show you something that I find super, super useful, and that kind of takes this to the next level entirely. because you've seen how RAG works to get you the information you need based on what you have out there, right? To get the LLM, turn it loose on your data. But this is an example that I like to provide that's a little off path and then comes right back onto path. So let's dive into that. So I'm going to go here, and instead of, we'll define a get mapping not for populate. We've already done that, but I want to use multimedia, multi-mode. So this isn't, well, that's just pretty terrible. So we're not going to do that. Sometimes Copilot, it anticipates based on however much you provide the information, the inputs. So in this case, I provided a mapping annotation, and it does its best based on that much information, what it thinks you might, or what it assesses that you might want. And sometimes it's eerily accurate, sometimes it's not. But again, the more information you provide it, the better decisions it can make, the better responses it can provide. So I'm going to just do a get multimodal response. And I'm going to create a couple of parameters in here. So request param, and I'm going to provide a default value. And I'm actually not going to go with this. That's just crazy. I want to provide a users mark Heckler files test image.jpg, I believe it is. And this is a string image path. And I also want to have a request param, default value. Oh boy, it just jumped right ahead for me. So we'll see how good this is. What is in this image? Yeah, so that's not terrible. We got our logger. That's fine. I like to log as we're importing things because that's super useful. Let's go ahead and get rid of this. And actually it pulled in all of this stuff, which is not at all what I wanted. So that was a nice try, right? So we'll say our image type, and we're going to use our image path. If it ends with a .png, right? Well, that's close. We can do a little bit better at that. So we'll use our MIME type utilities, and we'll say that this is a PNG. Otherwise, this will be a MIME type utilities JPEG. And again, just to neaten this up just a smidge. So there we go. We're defining our image type. And now what I want to do is do our media equals new media. Don't need that. So what we can do is if our image path starts with HTTP, right? What do we have here? Is that looks pretty good. Import. That's good. And did I bring in the wrong one? Hold on. Yes, I must have it. And there's my parent import from before. Yeah, that's right. Java.net.url. So we'll go with that and we'll see how far we get with it. Okay. So now I want to create a user message, and that looks pretty good. A user message is what you provide to the AI in terms of what you're asking. And I also want to provide a system message. And we will say new system message. And we want to say that if you can't definitively determine, and I'll say identify the image, do your best. It's always good to encourage the AI, right? So we have a couple of messages. Now all I'm going to do is return, oh, and this actually, I will need the chat model for this because this particular API is implemented through the chat model and not particular the general client, right? The client's a little bit more high level. So what I'm going to do is just import this as well. Very simply done. And then we will go back here. I skipped over that, and we'll import that as a constructor parameter. And now we can do our chat model dot call. We'll provide our user message and our system message. And there we go. So that gets us started. And the thing that this allows us to do, and it's still giving us this, oh, at exception, there we go. All right. So I want to show you this. This isn't directly related to RAG just yet, but it leads us to something really, really cool and really powerful. So I'm going to run this again, and I'm going to just do http colon 8080 slash, and what was the endpoint? Oh, mm. Do we have our default set? The default value is there, and what's in the image? We'll just start with that. That's fine. And the test image, I don't even remember what the test image is. Let's find out. Oh, it's a dog riding a tricycle on a paved road. Yeah, that's nice. Not particularly relevant, but that's nice. So it is correctly assessing what's going on in our image that we're providing. Now, I want to take this back into RAG territory because this is where it gets really, really powerful. Because now we have the ability to feed the AI an image and say, describe this image. But what I want to do is take this and say, how is this directly relevant to my domain? In this case, aviation. But again, it could be any domain that you choose based on the documents that you have, that you've gathered and determined the dimensions for and saved to a vector store. So I'm going to just create another endpoint, and we'll call this our image RAG and public string, and we'll say get image RAG response. And we want to very similarly provide an image as our default. That's not bad for a starter. And request parameter and default value. I actually am going to make this a little bit more specific. Tell me everything you can about this image. Let's see, how far are we going to take this? Just out of the gate. Yeah, that's fine. That's fine. And we'll make this our string message. That works. I don't necessarily need to go crazy about this because what I'm going to do is pass this off. I'm going to not repeat myself here with this. I'm just going to, first we'll do a get multimedia response. We'll pass our image path and message, right? But what I want to do from there is return get RAG response and pass what we get from our multimodal response to our RAG response. So first it's going to say, hey, if I have an image, what is it? And then it's going to pass that to our data store and say, retrieve any documents that are related to this. And now the LLM will take that and make it any specific relevance to our domain. So you can just take a photo, submit that, and it'll come back with something that is directly relevant to you, to the documentation that you have. So let's go ahead and run that. Boy, we're closer on time than I imagined. Let's go ahead and restart this. And I have a document here. Let's see if I can do or skip ahead. Yeah, so I just I did that. That's the multimedia. That's fine. We'll start with that. We'll hit the image path. We'll hit the multimodal endpoint and see what exactly this is we're getting. And what this is an airplane. In this case, it's a crop duster, but it's taking off and it's creating wingtip vortices. Very dangerous if you're behind a large aircraft, not so much a small one. Let's go ahead and do this, and we'll pass this same thing to our image RAG. And we'll take that same photo, that same image, we'll get the description of it. We'll pass that to our data store to provide that information as the seed. So here we go. Vivid, insightful. It's not on context such images. Oh, it's not. For some reason, it's not doing what I asked. Oh, I know why. Actually, image RAG and message equals. Tell me all you can about this image and its safety implications for a pilot. And we'll see what we get back there. That'll be a little more specific. So again, when it comes to AI, the more information you provide going in, the better responses you get coming back out. So we provided an image. We've specified we're interested in the safety aspects that result from this particular image. Can you help us out? So yes, it tells us right off the bat that wake turbulence is a real issue. Wingtip vortices can cause significant wake turbulence, which can be dangerous for the aircraft. Here's how you can mitigate that. Avoidance, that's the number one thing. Awareness and avoidance. Air traffic control provides separation between aircraft to mitigate the risk. Visual cues, watch out, stay off to the side, land long past the point that a larger aircraft lands in front of you, et cetera, et cetera. So this is a particularly powerful application of RAG because you can take a photo, say, tell me about it, and then take that and apply that to your data and say, tell me about that. How is that directly relevant to our concerns, to our documentation within our context, within our domain? So I want to go back and finish off because I know we're right on time. Whew. Wow. Didn't think I'd run out of time here. So more information is out there in the code repo. I have samples for the 3 listed, and I'm adding more as well as deepening the examples as I go. Helpful information is available at the links down below for the Spring AI Docs, OpenAI Docs, Azure OpenAI Docs, the pricing calculator. Please don't forget that. Be very aware as you do things, the spend that you're incurring. In most cases, it's not an issue, but you don't want it to become an issue. So just keep an eye on things as you go. Estimate before, keep an eye on after, and throughout. And Olama allows you to run different and try on different LLMs locally as well. So with that, let's go back over and see if we have any more questions, and then we'll pass it off to the next presenter. Oh, thank you so much, Paulina. Gracias, and appreciate you showing up and joining in. Krish, let's see. Oh, just going through the flow. Yeah, I try to kind of narrate as I go, Krish, but if you think of a question that's particularly that I didn't cover well, chances are I'm not happy with how I covered it either because time is limited. So please do reach out to me. Happy to explain any gaps that I left in there. So yeah, with that, I will turn it back over to Pamela and Ski, and we'll take it from there. But again, please don't hesitate to reach out. Happy to help. Thanks.
All right. Thank you, Mark. We appreciate it. It was a great session. I will ask that you take a second to give us feedback. If you have any opinions on the session, we are always open and we'd love to hear what you have to say. The event code for this one is going to be 23363. So we thank you for your time and we will see you on the next episode.
Hey everyone, hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.